Our new entry is on factoring ax² plus bx plus c. So that's when you have polynomials like 7x² plus 29x plus 4, where this coefficient in front of the x squared, or this squared term, isn't 1. We have a number there. So previously in our examples, everything we factored, there's no number in front of the squared term. Now we want to be able to use the x puzzle, but we're running into a problem that it doesn't work if there's a number in front of the x squared. So we have to use a strategy. And the strategy is called slide, divide, and bottoms up. It's also called the AC method in other books. So if you pause the video so you can write down these notes, the steps for factoring polynomials. We use this strategy when the degree is 2, which means it's a quadratic, so the degree is 2. The number of terms is 3, so it's got 1, 2, 3 terms. And the coefficient of the squared term is greater than 1. And the first thing we look for is to take out a greatest common factor. That's the upside down division that we went over 2 sections ago. So we always look to take out a greatest common factor first to see if it makes the problem easier. So you have to take out a common factor, then you have smaller numbers to work with, and you'll see as we start working with these problems, the numbers become quite large and the factors become quite large. So solving the x puzzle can be difficult. In our example, factoring 7x² plus 29x plus 4, we're going to use these steps. We're first going to see if we can take out a greatest common factor. So we look at the x's. So this is squared, x to the first, and 0. So I can't take out any x's. Can I take out a number? 4, 29, 7. So these are both prime numbers, so that's not going to work. So I don't have a greatest common factor, which means I can go right into this method. So this method's interesting because we want to be able to use the x puzzle, but we can't because there's a number here. So what we do is we take this a and we slide it over to the c. And that makes our new equation just x², no a, plus bx plus, and instead of just c, it's a times c. Let me show you what that looks like with actual numbers. So I can't use the x puzzle yet because there's a 7 here, but I want to be able to use the x puzzle to factor this. So I'm going to slide the 7 over. And my new equation, or my new quadratic, becomes just x² now, plus 29x, plus 7 times 4 is 28. And now I can use the x puzzle. So I'm looking for two numbers that multiply to 28, which would be multiply to a times c, and still add up to b. So I want them to add up to b and multiply . So now I'm just using my x puzzle. So two numbers that multiply to give me 28. Well, I know 7 and 4 because I just did that multiplication. 7 times 4, well, 7 plus 4 does not equal 29, so that's not going to work. 14 and 2, again, not going to work. Once you do more of these problems, you'll start to recognize patterns. One of those patterns is, if you notice the difference between these two numbers is 1, then take a look at what you're multiplying. It's probably itself and 1. Okay, so two numbers that multiply to 28 are 28 and 1. And 28 plus 1 is 29. So now we have our factors. So we set up our parentheses. X is my variable, plus 28, and plus 1. But I'm not done quite yet. So I multiplied 7 by 4 to get 28, and then I did an X puzzle. That X puzzle solved this factoring problem, but I need this one. If I were to FOIL this right away, I'd get x times x is x squared, but what I'm really looking for is 7x squared. So I need to undo that multiplication. Here's where this divide step comes in. I'm going to divide both of these numbers by 7, because that's the number I multiplied with. I want to undo that. And so it's divide, and don't forget to reduce. So when I reduce, I get x plus 28 divided by 7 is 4. And I can't reduce 1/7 any further. Now, if I FOIL that, it's still not going to work, because x times x is just x squared. So this is where this cool bottoms up trick comes into play. We're going to take the denominator of the fraction, which is the 7, and we're going to bring it from the bottom up to the front. If there was a denominator under the 4, we'd move that over here as well. So this stays as x plus 4, and I move the 7 in front of the x here to get 7x plus 1. And so now when I FOIL it, I'm going to get x times 7x is 7x squared plus x plus 28x and plus 4. So 7x squared plus 29x plus 4. And that's all there is to the AC method, or the bottoms up method. So one extra twist when you're factoring, and we have a coefficient on the x squared other than 1. So we have some more problems to do, but what you're going to do is tape this foldable into your book, or this handout. And just put one piece of tape on here, just like the other factoring handout. And we're going to do some examples over here. You should at this point be able to do this practice problem for 1, which is factoring 2x squared minus 3x minus 9. Don't move on to number 2 yet, because I haven't showed you how to do that one. Our new example is to factor 4x squared plus 38x plus 70. So we're going to use the same steps as we did before. Notice that I have a number in front of the x squared, so I can't right away use the x puzzle. But let's see if I can manipulate this somehow and see if I can. First I want to check is there a way to get rid of the 4? Well, let's see if we have a greatest common factor. These are all even, so I know I can take out at least 2. So I'm going to use my upside down division to take out a 2. So 2 goes in 4x squared, so that's 2x squared, plus 38 divided by 2 is 19, so 19x, plus, and then half of 70 is 35. So 2x squared plus 19x plus 35. That means that my new equation that I'm trying to factor, or my new quadratic, is 2 in parentheses, and then on the inside, what I have left over, 2x squared plus 19x plus 35. So now I want to go ahead and factor that. I still can't use the x puzzle because I have a number in front of the x squared, so I have to use my slide and bottoms up method. But by taking out a greatest common factor first, it makes the numbers easier to work with. So I want to just factor this polynomial right here, okay, this quadratic. So I'm going to slide the 2 over, and this becomes just x squared now plus 19x plus, and then 2 times 35 is 70. As I keep going down, The 2 that I took out always comes down with me. Okay. Now, you can wait and just bring it down at the end, or you can bring it down each step if you want, in case you're afraid you're going to forget. I usually just wait till the end, but I've been doing this for so long that I know I'm not going to forget. So it might be good practice for you to bring it down every single step. But now let's use the x puzzle. So 2 numbers that multiply to give me 70 and add up to 19. So think about that one for a while. One thing that you can do that might help is to make a T-chart of factors. So numbers that multiply to 70 are 70 and 1. That's 70 plus 1 is 71, so that's not going to work. Now what you could do is divide this by some number and multiply that by some number, and they're still going to give you 70. So let me give you an example. If I divide 70 by 2, that will give me 35. If I multiply 1 by 2, that gives me 2. And 35 times 2 is 70. But that just adds up to 37, so that's not going to work either. Let's try again. What if I take this 35 and I divided it by 5? That would give me 7. And I multiply that by 5. That would give me 10. 7 plus 10, that's 17, so that's not going to work either. Let's do it again. If I double 7, it gives me 14. And I take half of 10, that's 5. Well, 14 plus 5 gives me 19. So the more that you do this, and the more you familiarize yourself with these numbers, the better you're going to be and the quicker you're going to be at factoring these quadratic equations. So I broke this down into x plus 14 and x plus 5. And I bring the 2 down. And I know I'm not done because I have to do the next step, which is to divide, right? I did my slide, and now the next step is to divide. So divide both of these by the 2. I wouldn't use 4, because I got rid of the 4, right? Use a 2. That's the number that I slid over. So I divide both of those factors by 2. I bring this one down. The fact that that's 2 is just a coincidence. And I reduce. X plus 14 divided by 2, so it's x plus 7. And then x plus 5 over 2. Last step is to bottoms up. There's no denominator on the 7. If there was, it would just be a 1. And I put up a 1 here, so it would be 1x plus 7, which is just x plus 7. So we don't even bother doing that. We do bring this 2 over, though. So my final answer is 2. And then x plus 7, 2x plus 5. So it's just another procedure, another step for solving, is taking out the greatest common factor. If I hadn't taken out the greatest common factor first, my numbers would be too big inside. And when I went to reduce my fraction here, my answer wouldn't check out because the number I'm dividing by would be too big. There would be a greatest common factor you could take out. In each of these separately, and it would just be a mess. So always take out a greatest common factor first and just bring it along for the ride. Again, if you don't want to keep writing 2, 2, 2, 2, and 2, you can just write it here and don't forget to write it at the end, because you have to say it is part of the original quadratic. our final example before you do the on your own problem is to factor 6x squared plus 17x plus 12. So we first want to look and see if there's a greatest common factor we can take out. No variable we can take out, but numbers 6, 17, and 12, so there's no common factor in there. So there's no greatest common factor. And again, we want to be able to use the X puzzle, so I have to slide. So I'm going to take the 6 and slide it over to the 12. My new quadratic becomes x squared plus 17x plus, and 6 times 12 is 72. And now I want to use the X puzzle on that. So two numbers that multiply to 72 and add up to 17. So now it's getting more difficult, right? We have bigger numbers, bigger opportunities to fill out our X puzzle. Right? There's going to be more factors we have to check over. So just keep thinking. You could even with a calculator just do 72 divided by 2. Does that add up to 17? 72 divided by 3. Does that add up to 17? You know, and keep going. You can write out a factor tree. Another way you could do it is to take the birthday cake method on 72. Let me show you what that might look like. So we take 72, and we'll use the birthday cake method. I know 3 goes in there. How many times does 3 go into 72? It would be 24. I know 3 goes into 24 8 times. And then 2, and then 2, and then 2. So my factors for 72 would be 3 times 3 times 2 times 2 times 2. That would all add up to 72. I mean, that would all multiply to give me 72. So what can we do with that information? Well, let's start making combinations based on the prime factors we just found. So 3 times 3 is 9. 2 times 2 times 2 is 8. That means 9 times 8 would be 72. You could do 3 times 3 times 2, which is 18, times 2 times 2 is 4. That would give you 72. So you could do combinations of these factors and fill out kind of a factor tree of 72. Coincidentally, 9 times 8 is what we're looking for. So that worked out well. So now we're going to set up our parentheses. This becomes x plus 9 and x plus 8. We're not done yet. We have to undo that multiplication. So I now do my division. This is the 9. So I multiplied by 6, so I have to undo that. So I divide by 6. And then I reduce. When I reduce, I get x plus 9 over 6 can be reduced to 3 over 2. And x plus 8 over 6 can be reduced to 4 over 3. And now I bottoms up. So I take the 2 in the first one and put it above the x, which gives me 2x plus 3. And I take a 3 in the second one and put it above the x, which gives me 3x plus 4. Okay. So I've given you 3 examples, all of different things that should show up when you factor ax squared plus bx plus c. This one is when you have 2 numbers to bottoms up. That was the point of this example. The point of this one was that there was a greatest common factor. And then the original example was just to show you the method. Now your goal is to finish both of these problems and have your teacher check your answer.